Hi, I'm Elizabeth Parler, and for my final course project, I will be discussing ecological interface design. What is ecological interface design? Well, ecology is the study of the relationship between organisms and their environment. Ecological interface takes an ecological approach to behavior, analyzing the capabilities of the person and the constraints of the environment. In work ecology, this relates to the interaction of people with the interface of technology and the technology's constraints. Ecological interface design should make it as easy as possible to determine issues and the location of a failure. Skills, rules, and knowledge, or the SKR model, describes different cognitive levels of behavior. Knowledge requires information to be manipulated in the brain. Rules rely on familiarity and predetermined responses. Skill-based behavior is developed with time, comes naturally, and feels effortless. The main goal of EID is for people to use the much easier skill-based behaviors that are automatic, but resort only to the more conscious knowledge-based behavior in abnormal situations. Objectives are broken down here. This design differs from other designs because here our focus is on the environment rather than the user. We want to make sure that our design utilizes perception of the user and their action capabilities. So we want to make things visible and audible, and in cases of an unfamiliar situation or where adaptation is required, we want to enhance their intellectual ability, give them more information to be able to problem solve in those circumstances. So the designer should be supporting the development of novel designs, rethinking how to display things, identifying the information requirements by a systematic approach, and avoid detailed guidelines so that it's easier for the user to follow. Many common uses of EID is aviation, power plants, and healthcare, and many others as well. So how do you create an ecological interface design? Well, the interface is the intersection of the complex work domain and the human operator. So in order to analyze the complex work domain, we can use abstraction hierarchies to break that down. And then we want to look at the skills, rules, and knowledge of the human operator as they interact with the interface. So an abstraction hierarchy is shown on this slide here, and you work from the bottom up, the bottom of the image being the most basic level in the hierarchy. So you can see that as you move up through the hierarchy, you're analyzing what and why certain functions are done, and as you move down, you want to look at how the user does those. The taxonomy of the skills, knowledge, and rules is broken down again below, and those are just 3 different types of cognitive control that the operator could have to utilize. So skills are very basic, and you want to make sure that those are able to interact directly with the display and reduce the type of mental integration necessary for the operator to be able to understand what to do. Rules utilize visual constraints, and so you want to make sure that any kind of visual constraints or information being given is as salient as possible in order to tell the operator how you want them to act. Knowledge is a bit more complicated, requires a bit more mental processing, so you want to make sure that you create the correct mental model and make information on all levels as visual as possible so that it's a little bit easier on the operator. The design process focuses on 2 main important steps. First, you have to perform the work domain analysis using that hierarchy that we saw before and identify the variables and constraints at all levels. Secondly, you want to map that information to a visual form following that SKR model and the principles of design. So here's an example of an ecological interface design. On the left, you see what things look like when everything is going well, but on the right, you see that there's something looks amiss, there's probably some kind of error or some failure happening. And this design is actually used in healthcare. So you can see that there are many different factors that need to be scaled just right in relation to one another, and it makes it very clear what the problem is and what needs to be done to fix it. So what's the impact of EID? Well, ecological interface design improves performance. In a study comparing EID display to a conventional interface, it was shown that EID proved best for trials when failure occurred. So this interface is really helpful when adaptation and problem solving is necessary. It improves safety and productivity of complex systems, and the abstraction hierarchy process analysis identifies functional information that can improve performance. Here you can see references that I utilized for the presentation.